So yeah, this is a workshop that we've done around five times. So we usually do it every semester since there's quite a bit of interest, and yeah, Python is a very prevalent tool. Um, so a bit of an outline of the workshop. So the first part, which we're not going to look at today, was essentially on GitHub. So that's the other half of the slide deck before these. And we looked at various basics of Git and then also how to, let's say, effectively use GitHub for collaboration. This second part, so on Python development tips, we'll again cover some basics on virtual environments, how to use an IDE efficiently when working with Python, and then some different tips and tricks and tools that I use in my work that I in industry and also now in my PhD, and how we could also package this software with a tool called Poetry, which is one of the tools I asked you to install before, but no worries if you didn't. There's still time to do it and try out some of the things. And all of this is within so essentially there's a package which describes how to make a package and how to work on Python. So this is what's called PyDev tips. So you can find the documentation there. And inside the documentation, there's way more stuff which we can't cover in the workshop. For example, making documentation, doing unit testing, remote development, GitHub Actions, all sorts of stuff. But we'll try to look at these first 5 points mainly. So yeah, I already showed these slides. So if you haven't scanned it, here's a QR code again. If you came in a bit late, you can ask your neighbor. So this is the repo which we'll be working around with, which has all of these minimal examples of some of the tips that we're showing in this workshop. So there's the link to the repo and then for the documentation. And yeah, if you don't mind giving a little star, that would be nice to spread the word. So how many of you use Python? I think, okay, pretty much a lot of you, maybe a couple didn't raise their hands, but yeah, it's been really growing as a language, partly because of how straightforward and easy it is to use, and just the number of applications that it touches just through the libraries that people are creating with the Python language. So here's just a little snapshot. I think that they did a survey in the first half of 2024 where they saw Python was the third most used language. But the first two are web ones. So I guess if you want to look for something more general purpose, Python is the one that's really up there, essentially. And a lot of the discussions I get, especially in the EPFL or in the research community, is, okay, why should I go for something like Python, MATLAB? I guess you could also consider Julia in this. So if we clump Python and Julia into one, if we compare that to MATLAB, so MATLAB is what's considered a closed source language. So you have to pay for it, first of all, and usually we get this license through EPFL. And some of the great advantages of it is that, okay, there's only one tool for everything. So it's not open source. So it's one company behind providing these easy to use tools. And because of that, there's good documentation and it's quite stable due to the centralization. Whereas Python, or for example, Julia, on the other hand, is free to use, and you'll find many tools kind of to do the same thing. And sometimes this can be a bit overwhelming. Okay, which one should I use? Which ones are compatible with each other? So this is kind of what gets you into what could be called dependency hell. And then sometimes, since things are just moving really quickly, people are making a library, they may not be documenting it when they release it. So that can be some of the defaults, say the cons of Python. But the goal of this workshop is to make Python as convenient to use as something like MATLAB. Obviously, if someone else doesn't document their library, that wouldn't be the case. But the goal is that, let's say, when you maybe publish your software, you can follow these good tips so that your code is easier to use either by your collaborators or by other people if you want to open source it. So, and as I mentioned with this point, there's many tools to do the same thing. So a lot of what I present here is more personal preference. You can obviously find other tools that will do the same thing and maybe even better. But these are the ones that I've put together to present to you for this workshop, and many of them that I use myself. Any questions so far? So yeah, in the slides, feel free to go further if you feel like I'm going slow, or to go back, or also to just ask questions if something was unclear. So I saw this interesting Medium blog post, which was just released about 1 month ago, and essentially he was saying, stop making your projects like it was 15 years ago. Let me just move this. And essentially, I mean, Python now is it's starting to have some history, and when a language starts to when it's been used for quite some time, we get something called tech debt. Who's heard of this term before? Tech debt. So essentially, let's say, old ways of implementing things that just kind of stick around because no one wants to go through the effort of changing them because it's just more work and it works, so just leave it as it is. So he was kind of complaining about, okay, some of this tech that's there for Python, like, okay, stop using a requirements file, like stop saying in your README that's, okay, do pip install -r requirements, use a more modern tool for, let's say, packaging and managing your projects like Poetry, which we'll see, and then using tools to, let's say, format your code so it looks prettier and more accessible for others. So these are some of the things that we will look at. This is also covered in the package, but the rest, yeah, we won't have time to look at. But it's an interesting article to kind of keep up to date with, okay, what are the new techniques for working with Python? And since it's, as I mentioned, a free tool and open source, things are constantly changing. So sometimes it can be overwhelming to keep up with stuff. But yeah, luckily we have people who do blog posts like this to kind of keep up with the newest trends. So small reminder from last GitHub workshop. So this is first tip for this Python workshop. So usually when I start my projects, I like to start them from GitHub itself. So what I would do is I would start off as a private repository. So as you can see here, and I give the name of the project. Here it's this tool on development tips for Python. And the reason why I like using GitHub to start these projects is that, okay, it's already creates a remote instance of this project, and then it initializes it with a lot of boilerplate code that will typically be found in a project, such as a README. And I think the most interesting one is what's called a git ignore file. So who knows what a git ignore file is? Okay. Does someone want to describe it? Mark, what does it do?
So it tells you the files that you should ignore. Basically, when you git add everything,
yeah,
ignore this file.
So don't git add everything. But if you happen to be one of those crazy people that does that, at least this thing will prevent you from adding unwanted files. And what's nice is they have this template for all languages, and they have a pretty comprehensive one for Python. And the other interesting bit is adding a license to your project. All right. Oop. Yeah, something on the README later. So when you do this, you'll add a markdown file, but sometimes you may want to use another syntax for writing a README. And yeah, if you want to know more about GitHub, you can always just go to the earlier slides. Is the order okay? Actually, I forgot to ask one thing more logistic for the pizza. Is there anyone who's vegan or gluten-free? Okay. That makes it easier. Great. Okay. So that was the first thing on GitHub. That's how I essentially started this repo that we're going to look at to make our Python lives easier. So I mentioned this thing about dependency how where different packages may conflict with each other, which maybe one package requires one version of requests while another one requires a different version. And then your own target application is not going to be happy with that. And this can happen, especially, let's say, when you have different projects that you're working on, and maybe they need different versions of a particular library. So one common practice is instead of using the same version of Python with the same packages across all your libraries, is to create something called a virtual environments. Who uses virtual environments? Hopefully, most everyone. Okay, good. So as I mentioned, there's multiple ways to do the same thing. One way that I create virtual environments is with Conda. Another way that I also use is it's another library called virtual env. And the reason why I would use the latter is maybe if I'm in a more resource constrained environment, I would use something like virtual env, which is a lot more lightweight than the package managing system of Conda. Does someone use a different virtual environment framework? Okay. So one thing to keep in mind with Conda is that in the recent years, they've started to make some of their tools paid tools. So you technically need a license to use them. And it doesn't include the command line Conda, but more the graphical ones that Anaconda provides. So that's something to keep in mind if you're depending on those tools, especially in industry. Okay, but one thing I'll introduce today is another tool called Poetry. Who's used Poetry before? Who writes poetry? I'd like to hear that later. So let's look at Poetry. So the idea about Poetry, sorry that these things hide some stuff there. It's a tool for packaging Python projects, but also managing your different dependencies for this project. So it will handle a lot of this, and in a very kind of intuitive and convenient way through a command line interface. But then it also gives two other functionalities that are a lot more automated and easier to go about. Well, let's say when you're ready to, let's say, share your code with someone else. And that's those two steps are building your package, so into something that you would pip install like NumPy or SciPy, and then publishing that package as well too. So for example, if you want to put it in the PyPy server, or let's say private server of Python packages, you can publish it to this. So some reasons for poetry. I'll just list a few, and then we'll start to see a bit through the workshop. Is that one thing it can do is that it can automate the creation of the project files. So let's say you have poetry installed in your on your computer. You can run the command. Let me see. I don't remember it from by heart. Poetry new, and then your project name. And essentially, when you run that, it's going to create a folder with everything you need for a Python project. So it's going to create the README, so which would be redundant with GitHub if you had already done that. You can decide which one you want to use to create README. It will create a folder which should be the folder for your source code with this init folder, which is init file, which is needed for Python packages. A test folder if you decide to write some tests, and they're kind of nudging you, okay, write some tests. And then this PyProject file, which is necessary for packaging a project. So essentially, this one line will do that for you. And that's another way you can start your project as opposed to, let's say, from Git. So it does that automation. Another thing is that it provides a single command to create the virtual environment, but also install all the necessary dependencies. So instead of having to do all that conda create stuff that we saw before, or virtual m create, and then running another command to install dependencies, if you've already created a project like this, you run poetry install, bam, everything is done at once. And then let's say if you had to add some new dependencies to your project, let's say later on you realize you need pandas or something else. It gives you a one-liner, poetry add pandas, which will at the same time install it, but then also add it to your requirements of your dependencies. So let's say you were installing some dependencies and then you forgot to add it to your setup. It wouldn't happen in this case because it would automatically add it to this TOML file, which is used for setting up the project. And then, as I mentioned before, there's some simpler build and publishing processes than if you had to use other packages. Typically, you have to use other packages to do this. Here, they group it all into this poetry package. Any questions on poetry? Okay. So in the case where, let me move this thing. In the case where you've already started your project and you don't want to run new, you can also, there's an option of, okay, let's say you created it from GitHub, as I showed you, you've downloaded it locally, that project, you would run poetry in it then to create this necessary TOML file. So who's worked with this TOML file before? Okay. So we'll see it in a bit. Or who's worked with a setup.py file? Requirements.txt. Okay, I guess more people have seen that. So essentially it has requirements.txt, so all the dependencies, but more things related to the project so that you can actually put it into a package. And the goal of poetry is so that you can, not code like 15 years ago with the requirements file, but conveniently create this necessary setup file so that other people can reproduce your code and so that you can share your code. And the goal of poetry is to simplify this process. All right, so I see a lot of you have your laptops already, but now let's try to run some of this stuff. So if you haven't installed poetry already, so unfortunately there's a two-step process for this. So you first have to install something called pipx, and then with that from the terminal you can install poetry like this. And then one extra step that I do is or that I recently do, I only recently started using poetry, is running this command. Because by default, so I mentioned that poetry creates a virtual environment, but this virtual environment, will be hidden in some cached directory. And maybe you don't know, you don't want to have to search for that environment in random places. But what you can do is you can run this command from the terminal so that you set by default that virtual environments are created in the same folder as your project. So I think it shows up as a .vnv folder essentially inside your project files. So yeah, you can make sure you install Poetry. And then what we'll do is you're going to try to locally install PyDev tips on your computer. So hopefully you're familiar with Git by now if you either did the workshop or you know before. So you would clone the project files. You would go into the project files. Here we're going to create another virtual environment. So if you have Conda, if you don't have Conda, you can skip to the next slide. So one reason maybe I would use Conda is that, okay, if you want to be in the situation where you want to use the same environment between multiple projects, that may be a reason to use Conda. But yeah, one thing to keep in mind if you're using Conda, especially if you're using Python 3, which I guess everyone should be, is to explicitly say Python 3.11. Because otherwise, the Python executable by itself may not exist. It would just be a Python 3 executable, which could lead to some issues later on. And then with Conda, you could see which are your available environments. So ideally, you've just created this project env1. You would activate it. And then when you activate an environment, it puts it in, let's say, parentheses in your terminal. And then as if you have Poetry installed now, you can now install the source code of PyDev tips with this command, Poetry install. And this second part is optional. So what we'll see later on is that you can have optional dependencies. So in this case, I have these dependencies, which are if you're in a development environment, you'd want to install these dependencies. We'll see that in a bit. And then another thing we're going to install are pre-commit hooks. We'll come to that in a bit. Yeah, question? Yep, yeah. Go ahead and run them now. Yeah. Sorry if that wasn't clear. And then we'll explain each of these things throughout the project, because these are essentially when you've, let's say, made a package that's ready to use, ideally, these are the steps that someone would need to follow to then download the source code and be able to use your library locally if they were developing it local, if they were wanting to make modifications to your source code. Otherwise, you would just have to do pip install pydev tips. So if I go to this link, the way you would install NumPy, you would just use this. But let's say if you wanted to edit the source code of NumPy, you would have to go through steps like this, such as downloading the source code, creating a virtual environment to be able to modify that source code, and then any other dependencies for development situations. So yeah, these things on pre-commit hooks, and we'll talk about in just a bit, so don't worry about it for now. And then as a way that you can check your code, so what usually people do is they provide some, say, test script or example script. Here you can run this pytest command in order to run the tests for the package. So I'll give a few moments for that. And if there's any questions, you can raise your hands. I'm just going to switch to the next slide to just show if you didn't have Conda on your computer, but you have Poetry, which you would need to install the source code, it would be similar steps. You get the source code, you install the package locally, install these pre-commit hooks, which we'll talk about later, and then instead of running just pytest, you would run Poetry run pytest. Essentially, this Poetry run is what you would have to run, what you'd have to enter before every Python related command. So yeah, if you wanted to do run a Python script, since you're not inside a virtual environment, as we were in this case, you'd run Poetry run and then Python your script. Anyone have any difficulties? Let's see if there's anyone on Zoom. Right, I'll move on ahead then. So now with those previous steps, you've downloaded the source code, you've created a virtual environment with which you can code with that source code. Now we're going to see, okay, how can now we edit these files conveniently? So this is the step of using an IDE. So IDE stands for Integrated Development Environment. And as I mentioned, in open source, there's many tools to do the same thing: Visual Studio Code, PyCharm, Replit, Spider, et cetera, et cetera. So how many of you were using VS Code before this workshop already? Okay, so more than half of you. So we'll look at this tool and just some of the features that it provides for development. The main reason why I went to VS Code, so I started with PyCharm, was that I wanted to do remote development, but on the community, on the free edition of PyCharm, that wasn't available then. Maybe now it is. But VS Code has a really easy way to set up. Let's say you have your source code in another machine and you want to be able to connect to that machine and code with that. So why would you want to use an IDE? There's many reasons here, just a few. Syntax highlighting so that you can get an idea what are variables, what are the functions. Indexing, and indexing is essentially creating a map between all the functions and variables so that if you need to rename things, it's easier. And it's easier to navigate your code base in that way. So yeah, I think I had this meme in the previous GitHub workshop because it also helps a lot with version control. So make your life simple and use an IDE because it kind of centralizes all of these tools in one place. So yeah, looking at VS Code, here's the download links if you haven't downloaded it already. So we have our project now on our machine. We're going to open VS Code and open it. So essentially it's with this open folder. And then once you open the project, go inside the examples folder. So for example, to this real convolve.py. And then what we want to do is we want to set the virtual environment that we've created for this project. So by default, it may just pick some default Python from your computer. But what you're going to do is you're going to click on the bottom right corner. So like this, boom, and it's going to open a drop-down menu where hopefully you can find the virtual environment that you've created. And then you can select that one. So if you don't see it, and if you did the approach using Poetry, so these are just more some debugging slides, you can run poetry info, and that will give you the path to your Python. You can also run which Python from inside your virtual environment. So for example, here I'm in a Conda environment. If I run which Python, it'll tell me where's the location of the Python. Because if you don't see it in the dropdown, what you can do is you can copy that path. And then when you click on that bottom right corner, there's this option of enter interpreter path. So then you can enter your virtual environment in this way as well too, in case VS Code hasn't detected it. And if you didn't create a virtual environment before opening VS Code, you can also create one from VS Code. So same thing, you click on the bottom right corner. There's an option, create virtual environment. You can pick which tool to use and then which version of Python to use for that virtual environment. All right. Any questions on setting the virtual environment in VS Code? Yeah. It's this one, poetry info. You ran this command or? So in this one, I'm not in a poetry. I think in this one, let me go to. It's fine. Okay, we can see later. I think here, maybe yeah. So here, for example, I made the settings so that it creates the virtual environment inside my project files, which we see here. So I would copy that path for my Python. All right. Okay, so now there's no other questions. Let's look at various features of VS Code that will be useful. Okay, so I mentioned this thing about indexing, so it makes this map between all your variables. So let's say you pick on a specific class function that you decide, okay, this name isn't very convenient or it doesn't represent this object very well. So you can pick this option, then right-clicking it to rename the symbol. To then change it not only in that file, but everywhere else in your file. So let's say you have a super complicated code base with, I don't know, tens of thousands of lines of code. You don't have to remember where each of those usages of real of R50 convolver in order to change them. And then also when you, let's say when you click on it, you'll see it gets highlighted on its different usages elsewhere. But yeah, also to show, let's say if I go to there, to that file, so that file I was looking at was here. We have sync convolve. So there's also option go to find all references. So then you can see all the files where it's being used as well too. That's something that's also quite useful for debugging purposes. So how many of you debug with print statements? I know you all do. You can all raise your hands here. So the goal of this part of this workshop is to show you, okay, how can you properly debug? So that was part of the reason why we wanted to set the virtual environment within VS Code, so that we're going to run our code through VS Code so that we can debug like civilized people with breakpoints. So let's see that. So for example, if you put a breakpoint in that same class, which I showed you, you can follow along, or you can just look at the slides to see what the process would be. Process would be, okay, there's a thin column where you can set a breakpoint. So that's what I've done here. And when you've set it, you'll see this red dot. Again, as I mentioned, make sure your Python is correctly set to your virtual environment. And then on the top right corner, there is this little play button where there's an option for debug Python file. So we're going to select that option. And okay, what's important is that you want to select that option from a script. So for example, if you run it from here, it wouldn't make much sense because it's not a script that's calling this. So let's say if I put the breakpoints, I don't know, here, you would want to put it on in a script, for example, one of this example scripts. You'd want to do debug Python. So it seems like they changed it a bit. This debug Python file option there. Because then this is going to call our think convolve in which we put the breakpoints. Okay, and then when you've launched in this debug mode, you'll see some options that appear. So there'll be this little menu that comes up in the top, and you'll see that the code has stopped in this highlighted line. And then there's various options where, it stopped at this point. You'll get this console on the bottom where now we can enter different commands. For example, maybe you want to check the length of a certain array. You want to plot it to see if it makes sense. And this is, I guess, as you can imagine, much cleaner than doing a print statement, or let's say putting a matplotlib in the middle of your code. Here you're literally stopping in the code, and then now you can really work interactively with that code. And then you can then step through different lines of code with these commands here. So yeah, code stop the breakpoints. You have this console where you can interact with the different variables. So in those variables, I think we see them here. And then, for example, as I mentioned, you can interact with the different variables, even plot things. Those should pop up. So that's one of the main other big reasons of using IDE. And I know a lot of people don't necessarily like or do debugging. I'm one of those sometimes, but it's a very good practice. And at least now you can see how it can be done with VS Code. And as I mentioned, you can also see those same stepping commands going to the next line if you go under this run menu. All right, any questions on debugging? All right. So another useful thing with VS Code is they have these what they call extensions, or plugins, let's say, in different software. One that I use all the time is GitHub Copilot. How many of you use some sort of LLM within the IDE? Yeah, I guess. How many of you find it useful? Yeah, I guess the same number. Yeah. So it's going to be wrong a lot of the time, but at least it's a very useful starting point. Like, for example, let's say you're copying different versions of the same code, or if you need to index some crazy array, it does a pretty good job in figuring out how to do it. And also it uses the context of your other files to then help you figure out, okay, what are the next lines of code? So just a bit of demo on that. So a lot of the code that I did for this demo purposes of this package was generated with GitHub Copilot. So for example, the way the interface works is that you'll start typing, and all of a sudden you'll see like this grayed out thing. And essentially it's Copilot suggesting, okay, do you want this as your next lines of code? And then you can press tab to accept it, or escape if you want that suggestion to go away. And one thing that it's really useful for is for generating documentation. Let's say you've already written your source code, and now you just want to write some what we call doc strings to kind of say what are different parameters and what is it outputs. It does a pretty good job in generating these, at least giving a starting point. This is very good because it saves so much time. And I think yourself and also your colleagues will be happy to have a little explanation about what the code is doing. You can also use it in the other way, where you use comments to prompt the copilots. So for example, this script, which was the base for that script inside the examples folder, was generated from me just putting comments. And I just had to maybe like tweak different indices here or change the number of subplots because they can't read my mind to know how many things I want to plot. But yeah, so it can work in both ways, giving comments to prompt it like you would from ChatGPT, or you've already written your code and asking it to document it for you. And in terms of productivity, this is so nice because then you don't need to switch between different windows. You can have one window where you're having your coding, you're having your LLM, let's say Copilot, and also, as I mentioned before, where you have your version control all in that same place. So that's super convenient. And so using Copilot, so if you have an EPFL account, it's free through what's called the student developer pack. I think I maybe mentioned it here. Yeah. So if you follow this link on this slide, student pack, it'll take you to a GitHub page where they'll just ask you to give, let's say, your EPFL enrollment info, or even if you're working at EPFL, you can also get it for free. And yeah, then essentially it comes up as a extension here, which I can deactivate or activate, so I can toggle its usage there. And there's also free alternatives extensions. So I don't know if this one still exists since I put this down when I first started the workshop, but there's all sorts of alternatives. I'm more familiar with Copilot, but yeah, I'm sure others can work quite decently as well. Any questions on Copilot? Okay, now let's switch to one of my favorite tools, Hydra. How many of you know about Hydra? Okay, only Alien. Some people are smiling there. You know it or no? You don't know it? No, you don't know it? Ah, the movies. Not for Python though. Okay. So let's look at Hydra. So I think I mentioned it 2 weeks ago during the GitHub workshop, how I'm not a fan of Jupyter notebooks. Yeah, I think I mentioned that. And one of the reasons is because, especially when you're dealing with really complex projects with, let's say, even 10 different parameters, it can be prone to error because maybe you didn't run a specific cell for that parameter to take effect. So what I like is instead is to depend on scripts so that I know that all the variables and all the code that I wanted to run before was run instead of having to restart a kernel and then run the whole Jupyter notebook. I mean, I do like Jupyter notebooks. I'm not saying I hate them for demo purposes. Once I know something's working well, I would put it in a notebook for its explanatory and demo purposes. But if you're having projects which have huge sets of hyperparameters, I would switch to using scripts. And one thing that people start to do when they use scripts is that they have all these command line arguments. So how many of you have used something like argparse and click for? So if you've used this, you probably had this experience where half of your code file is just arguments, right? So what Hydra lets you do, it essentially does multiple things. One of the things it does, it compresses all of those parameters into a single line of code. Because what it does, it separates code from configuration. So that in a separate file, you define your configuration in a kind of like in a YAML format. So you can have really nested dictionaries and all sorts of rich ways of describing your parameters. And then your Python script is going to identify which configuration it should use to then do all the subsequent processing. So I have this little blog post which kind of goes into more details about some of the features that I find super useful. But we'll look at some of them now in practice within this workshop. All right. So for me also, yeah, it also helps a lot in terms of reproducibility because then what it does, it generates also these output folders where I can store my results. And by default, it also stores the configuration I use for those results. So I know which inputs led to which outputs. So let's say I want to be able to reproduce an experiment from, let's say, December or October 2nd. then I just open that folder and then I can look into the configuration to see what produced it instead of having to run every single configuration possible to see what led to the outputs. But yeah, let's see some of that in practice. So I mentioned if you start to create a command line interface with Python, you may have all these, you may need to create one line, at least one line for each parameter of the command line interface. What Hydra does, it compresses that all into one line, because essentially what it does, it says it's going to look into this folder or this file to find all the parameters. So inside this defaults, for example, I've defined different things for this convolution script. So let's say a random seed, because I want to generate a random signal, the length of that signal, and also the length of the filter I'm going to operate that signal with. So, and then I have some optional config here for storing outputs into the output folder. So then what happens is if I want to, let's say I had 1,000 parameters in this file. And if I only wanted to change, let's say, two of those parameters for, let's say, a different variation of that experiment, what Hydra also lets you do, it lets you inherit configuration files from default ones. So for example, here, I'm defaulting to the parameters here, and then I'm overriding the filter length to 25 when it was previously 10. So this is a very dummy example. It seems kind of silly just to create a new file for this. But when you have, let's say, hundreds of parameters, if you only need to change a few of them, it's much cleaner just to have those couple of parameters here rather than a huge list of them, so that you know that, okay, you can name this experiment, let's say experiment filter length, to then know what different configurations are for which outputs. And so I mentioned these output folders that it creates. So I gave an example. Let's say I want to look back into my results from February. So what I did here is, since I did this thing about changing to the output folder, I'm storing some output results. So here's a picture, but it could also be data. And now it's writing that data into this output folder that was automatically created by Hydra. I don't know, maybe some of you have run some scripts where you create a folder and then you write into that folder. How many of you have done this before? So with Hydra, you don't need to create the folder. It's already there for you. And then it's going to store all the outputs there that you want to write. And then inside this Hydra folder, so this one here, so I'm going to expand it, I have the configs that I ran, the parameters. So this was back in 2023. Maybe in 2024, I had changed my default parameters to something else. And then I'm thinking, why am I not getting the same results before? I can go back to my previous run that I had in 2023 and see that, okay, I ran those parameters. Because even if the config file changed, it wrote that config into this output folder. So this is really great for reproducibility and when you want to revisit experiments that you've done before. Any questions on this? All right, so that's just a little preview into it. In the blog post, there's some more info on this. For example, you can create complicated structures within your configuration, because maybe you have a dictionary where you have, let's say you're doing some sort of machine learning training where you have training parameters, eval parameters, and you can have a nested thing there. And then in your Python code, you just have that one liner to just interface. And then essentially, instead of having all of those, and then essentially to set the parameters from the command line, we have this comp1, which was this dictionary, where now I can just index like this and then override the parameters according to my specific experiments. So yeah, it saves a lot when you're dealing with complicated projects. Yeah. YAML, yeah, it's I would say it's even simpler than JSON. So in the project files, we can take a look at them. So the way I've structured it here is that inside examples, we have this script real convolve, which is the main script. And then by default, it's using this file called defaults inside the configs folder. So if I open it, defaults look like this, and it's much simpler than a JSON. It doesn't need all these brackets around it. So it just has parameters, and the way you do an equal sign is with this colon, essentially.
Just compiling these YAML files.
So it's parsing the YAML file. putting them in a dictionary called config, which you can then parse within your code. Then it also creates these output folders whenever you run your script. So for example, let me try running let me run this here. Oops. So I created this plot. And then if I go to my project files under outputs, there's a new folder for this date with the configuration I ran for it. And yeah, if I overrode any parameters, which I didn't, let's say if I wanted to override a parameter, let's say seed, the way I would do it would be seed equals 2. So then it would run it for seed 2. And then we would see that now there's a new folder with a new timestamp where I look at the config. Now it's seed 2, so that in case I changed it in default, this thing is always there. And I can know what parameters I overwrote. And then here I see my different outputs as well too. Well, config files, like it's lots more suited to config files than JSON, mostly because it supports commands and it's actually readable like JSON. So it's better, it's more human readable, yeah, for sure. There's another formats that's, I guess, did you talk about Tomo yet? Tomo will see it for the setup of the project. Yeah, so Tomo is another format that's really suited to config files because it's very readable. Yeah. So that's a little preview into Hydra. So very useful if you have different types of experiments. And when we think about about version control as well too, let's say if many people maybe without Hydra or without some sort of command line argument, they would write a script where they have all the parameters at the top of the script. And they would comment out the ones for a particular setting, uncomment for another setting. Does it sound familiar? It sounds familiar to some of you. And the issue with this is that when you're dealing with this in version controls, that whenever someone uncomments or comments something, even though it didn't change the code, you're creating now new changed files in your project. But by separating the configuration, your code files are never being changed. You're never adding this into your commit history. And you only have to define new config files if it's needed as well. So you avoid, let's say, huge commented stuff just for configuration or huge lines of configuration from your Python script because you just separate them. And it's also better for when you're working in collaboration because let's say Adrien and I need to use the same code. We'll just have our own different configs without ever changing the source code itself. Yeah. Any other questions on Hydra? Yeah.
Large scale projects or this is something you want to trying something, but
Definitely for large scale projects. If you're just, let's say, in a hackathon setting where you just want to try something for a weekend, probably you don't need Hydra. But more when you want to make sure you're being methodological with your code and that you're not introducing errors, like if you're using Jupyter notebooks, or to make sure if you're collaborating with people that you have your separate configs if you're testing different settings, it's better for this. Because also in this dummy case, it doesn't really add so much to this. I mean, yeah, sure, I don't need to comment and uncomment maybe 2 lines of code, but as your number of parameters start to grow, especially which is the case when you're experimenting in machine learning or maybe some simulation experiments, that could start being useful to have something like Hydra. Any other questions? All right. So let's get back to the slides. You can close this one. Okay, so we talked a bit about organizing your code files. Now let's talk about, okay, how some techniques, simple tricks that you can actually speed up your code. Some of them are maybe quite obvious, but it's just there for completeness. So one of the main things, for example, if you use a library like NumPy for linear algebra, for matrix operations, is to avoid for loops. Really try to take advantage of vectorization and broadcasting. So broadcasting is the idea that maybe you have a 4x4 matrix and you need to add a column or a row to that 4x4 matrix. Instead of looping over each row or column, you can make a 4x1 column or 1x4 row and then add it, and then it'll figure out the dimensions to add that same column over. And yeah, I just put some links to some example scripts where you can try comparing the different approaches yourself, the slow way and let's say the better way with vectorization and broadcasting. Another library that I find myself often using, especially in simulation settings, is something called joblib. So joblib is just some wrapper around multiprocessing, which tries to put multiple jobs on different CPUs. And it just provides a really easy to use interface to parallelize over, let's say, tasks which are completely independent from each other. So for example, one application where I would use this was when I was working in speech recognition, we would need to simulate different types of rooms or simulate different types of audios. So those are different scenarios. So there's no reason why I need to run one, wait for it to finish, run the other, wait for it to finish. I can run it, I can try to spread it across multiple CPUs. So joblib lets you do something like this, where in this case, I just define a stupid F function here. Is it? Yeah. Where yeah, I just define a function here and I pass it to this parallel and delayed option to then spread across the calls of this F over multiple. So there's different random seeds, so they don't depend on each other. So that's it's just going to do it separately rather than doing it in a serial process where here I call F one step after the other. And here, for example, I mean, this speed up will depend on the number of CPUs you have, but here, I guess I had 4 or 3 CPUs. It's sped up looping over these different independent cases by a factor of 3. So yeah, I think if you click on here, you can see the very dummy example of using it. And in this example script, you'll see how that F is actually defined. So the F is just, I wait for a specific amount of time and then I return. So obviously if I'm waiting one after the other, it's going to be slower than if I wait in parallel. So yeah. For GPU support, so there's multiple libraries you can do this. You can go directly and use an ML framework like PyTorch, TensorFlow, or JAX. If you want something that's a bit more out of the box to use, especially if you're already using NumPy, there's a package called QPy. Who's used this before or heard of it? Okay, so essentially what QPy tries to do is they try to give the same functions as NumPy with the same interface. So as you may, I don't know if you used PyTorch before, but maybe you'll notice that for some functionality, the function name will be different. What QPy tries to do is that it's going to be exactly the same name so that you can then import, I think it's in the next thing. Yeah. So did I do it here? Let's go to the example scripts. So that if you have QPy installed, maybe I did it a different way. You can either, so that I wrote some boilerplate code to do this. So, um, so yeah, this was a trickier example because for the FFT they have a slightly different interface, but the idea is that instead of importing NumPy as NP, you could import QPy as CP, and then CP1s, CP0s, CP mean is the same as doing the equivalent functions on NumPy. And what some people do is that they'll try to import QPy as XP. That doesn't work. They import NumPy as XP. So then you can then just use XP later on in your code as either QPy or as NumPy. So this is one way you can speed up your code just by performing the operations on the GPU rather than on the CPU. So yeah, obviously depending on the GPU here, for example, I got a 10x speed up by calling this FFT function. So those are just a few tips and tricks to speed up your code really quickly without too much extra overhead in code. But yeah, maybe you've seen some of them before, but the idea is that you have these different example scripts to see them in action and also links to those packages to see how you could incorporate in your code if you just need to speed up a small process. Any questions on that? All right. So now let's talk about packaging. So how many of you use open source software? Yes, all of you probably at some point. How many of you have open sourced software before? Okay. So these next few steps will show you, okay, how would I make my projects pip installable? Like, how could I make it easy to use for other people? So we kind of saw those steps that we ran at the beginning of the workshop where you pipt install, or where you could have either pipt installed PyDev tips or you install it by source code. So this packaging approach will let you do both of those. Either someone can pip install it or they can install your source code so that they can quickly work with it to make modifications. Because the easier you make it to work with, the more contributions you'll obviously get for the code to improve it. So one necessary component, which we saw with Poetry already, is having this init file within your source code. So if you use Poetry to do Poetry new, your project name, it automatically creates that for you. So there we saw one of the advantages of using Poetry. Yeah, so as I said already. And the other important part is, so Adrian mentioned this, is a file called a TOML file. And the TOML file is essentially specifying what are the requirements and what needs to be installed for this piece of software. So TOML is one way of specifying this. As I mentioned in Python and open source, there's multiple ways to do the same thing, but more and more this is becoming the standard of doing stuff just because it's much more readable and there's a lot of good tooling around, okay, how to interpret these TOML files. So one of the benefits of using Poetry is that, okay, if you were starting from scratch, your TOML file will have been already created and it'll have the real bare basics that you need for it. If you did init, let's say you already had your project files and you decide, okay, I want to use Poetry to manage my dependencies. When you run init, it's going to walk you through a series of questions like, okay, what's the name of the package? What's the version? Give me a name. What packages are needed for this? And then it's going to generate this TOML file for you. And one of the more important parts of this TOML file is this build system here, which is essentially saying what backend am I using to build the package. So Poetry is one of them, but you could use all sorts of other things, which I've linked here as well too. But Poetry just gives this framework to do many other things more than just packaging. And I also mentioned how you can interactively add projects or dependencies to your Python project. So whenever you run Poetry add, as I mentioned, it's going to install that library, but then it's going to add a line here. So essentially all these 30 lines of code, I didn't write any of them except these two. And the main reason I had to add it is because I had my documentation written not in Markdown, which Poetry assumes, but in another syntax. But everything else was generated by Poetry, so I don't need to manually think about which version of a software I need to avoid this dependency hell. And then I also mentioned how, so here we see two groups of dependencies. This is the main dependencies which will be installed all the time. And before, perhaps you saw a command where I had something like Poetry install with dev. So that's saying that, okay, I want to install these extra development dependencies. So essentially it's going to look for a group called dev and install those dependencies, which is what I need in this context. Otherwise, by default, it's just going to install these ones here. So as Adrien mentioned, it's supposed to be a much easier file format to read rather than a setup file. And it looks very similar to a requirements.txt file, so it shouldn't change too much, maybe what most of you are already familiar with. But it has this Poetry tool around it to make sure you can avoid all sorts of messes when packaging code and installing the code on another machine. Any questions on this part? Yeah.
For the defaults, it takes your configuration and puts it there. It doesn't check whether your code needs Python 3.10 or it works with 3.9.
So
you can 3.9.
So when I run this Poetry install command, it's going to look at multiple things. It's going to look at the version of Python it needs. And then it's going to also install all the necessary dependencies with it. So, because before what you would have to do is you'd have to, I'm just going to write kind of pseudocode, create environment, install code. And essentially with Poetry install, it's doing both of those steps at the same time. So it's already knows that these dependencies are what's needed and this version of Python is needed. And the TOML file is just specifying it so Poetry can then reproduce that environment with the necessary dependency.
The TOML file was generated by Poetry.
So it was generated by Poetry when I was happy with the state of my project, or I had to tell it, okay, I want to use these packages, and then it created these list of dependencies and and versions for that project. So it's either you can tell it, I can also write manually which versions I want. Or when I do this Poetry add numpy, it's going to add it to the line. When I had to run Poetry init, it walked me through a process, say what packages need to be installed, and it's going to make sure to install the ones that are compatible with each other. I don't know if I can run it again since I already did it. Can see what it does. Yeah, it's going to complain that the TOML file already exists. But, any other questions? All right. So then, as we saw in the previous way, the second way in terms of installing a package, then if someone were now to use your code, they would clone your repo. For example, they would install it with this dev group if they needed it. And these two are also optional. But already with Poetry installed, now if they enter a Python environment, we can do import py-dev-tips. So they can interactively work with this package, make some modifications. It's going to be modified instead of, I don't know if you had to do this before, we have this sysappend, I don't know, some long thing because you wanted to add some source code that you're working on inside your environment. One of the advantages of packaging your code is that you can avoid these annoying things and really do imports as you would for like NumPy or whatnot for a local project. Yeah.
It's during the hackathon on a small project.
I would, but it depends how. For me, it's really quick to set this stuff up, and especially then if, because in a hackathon it's really an environment that's prone to bugs and errors. So then, if you're quick to make an environment where you can avoid these errors, the better. But it's not necessary in hackathon. Maybe more for your work or your school projects where you just want to make it easier for you to, let's say, reproduce it on a different machine if you have to go to another machine, or if your colleague needs to now use your code that they can use it in a very convenient way. It's good to package it in such a way. Any other questions? And that's one of the nice things about Poetry. Like if I may just go backwards, just create Poetry new dummy project. Maybe this is what I would do at a hackathon. I just create it and now it's already done. All those files are created. So we have the README, we have this dummy project, and we have the TOML already created for me. So let me just look at what that TOML looks like, so you can see what it looks like if you just start from scratch. It just made dummy project, initialize it to like a very minimal version. It already has info about me in my email. It's defaulted to this version of Python. And then let's say now I realize in my project, okay, I need to add NumPy, as you mentioned, Poetry, add NumPy. Oh, I need to change virtual environment. So let's first install. So now I created this virtual environment, this .env. So .env, and now I want to Poetry add NumPy. Now it's installed NumPy, but at the same time, if we now open this Vim file, we'll see NumPy has been added there too. So I didn't have to like manually add it. And let's say I pushed it during in a hackathon and I forgot to add it. It's already been done for me. I don't need to have this extra step doing something. So yeah, any other questions? Yeah. So you could do it from a VS Code terminal. I'm just doing it from a normal terminal. Because yeah, the terminal that VS Code provides you, where is it again? It's just a normal terminal here where you could do the same stuff. You just have to make sure you deactivate. you don't want to maybe mix up environments, but you could install it with the project env as well too. I think what I was missing before, the reason why it didn't work is because I didn't run poetry install, but then I would overwrite my conda environment. But yeah, you could also do it in the console there. I often switch between VS Code and an actual terminal, mainly because just to have to be able to see more lines of code on VS Code. So that's why you'll see that I switch between the two like that. Any other questions? Okay. So we started to see a bit on the Tomo file. Now I'll talk about code formatting, which is that other point that guy made about not coding like you're 15 years ago. Ah, looks like it's that. So there's actually a standard in terms of how Python code should be formatted. It's called this PEP8 style guide. I think if you open it, you wouldn't want to be bothered with reading all of this stuff. So luckily, there's tools that can automate the formatting. And one recommendation that the guy was making and what people do is to install these tools to automate that process, but to also install them such that it's already in your workflow. And the place where people typically add it is whenever you use git commit. So when you run commit, it's going to make all these checks, fix your code if needed. And if it's not happy, it's not going to let you commit your code. Sound annoying, but it's helpful. So essentially, if you did this poetry install -- with dev, it will have installed these necessary packages for code formatting. Otherwise, you can manually do it like this with pip install. And then what you would have to do, which is what we saw in that huge block at the beginning of the workshop, is run pre-commit install, which now is going to install these git pre-hooks so that it's going to run these checks when you try to commit your code. So the first time you try to commit your code, it's going to go through these checks and it's going to give a fail if it notices that you didn't comply with one of these formatting things. And again, that can seem annoying, but it's better than you having to go through the whole list of style conventions to look at your code to know where you need to fix up things. And the way they run is that they'll actually run in the reverse order. So what will happen is black will try to fix everything it possibly can. iSort tries to order your imports, and then flake will kind of complain about the things that need some manual intervention because maybe it's not super obvious. So that's kind of what we see here, where it's fixed up FFT convolve because it realized, okay, things weren't formatted well, and then Flakegate was still complaining about certain things that, okay, need to be manually checked at. And then since black changed those files, before you commit again, you actually need to git add those formatted files. So that's what we see here, that these files are in red or on VS Code. You'll see that they'll appear with the M and you need to re-add them. And then you may have to try again to then make sure they pass. So let me just do a quick demo of that. So I'll purposely add some bad formatting to this file here. So let me just put some weird spacing there. Another weird spacing here. And then if you remember from the previous workshop, or if you're familiar with VS Code for source control, it'll show up as modified here. And I will see that these lines of code are modified. Okay. And now let's see if I correctly installed the pre-hooks. So now I'm going to try and commit this file. So if you remember from the previous workshop, there's 3 steps. I add the file and I write my message. Some changes, obviously not a great commit message. And I try and commit it, but bam, I get this message that's complaining that, okay, there's an issue with the formatting of the code. So what I do is then I show the command output. So then here I can see that this file was reformatted. And now Flake8 is happy. iSort is not happy. So if I open this file again, or if we see it from the version control, we'll see that the changes I made down here have gone away now. It wants to do it all as one line, which is what the convention is. And actually, I've never run iSort on this file, so it's actually changed the order of things. But since it's a modification, if I try to commit again now, it's going to still complain. What do I need to do so it doesn't complain? The file has been changed, so why is it complaining? Exactly, so I need to add it again because the file has changed from isort. So now if I commit, now I'll be happy and then I can push the files now. So yeah, those pre-commit hooks are sometimes going to be blockers when you really want to push something quick, but then it's also making sure you don't push ugly code quickly. And those are good precautions to have in place. Any other questions on that? Okay, so let's look at this last part that poetry covers, which is building the project and now publishing it to, let's say, a remote repository like PyPy. All good? Right. Thanks. So with poetry, again, a few things that need to be done first time. So if you've never published, if you don't have a PyPy account, which is essentially this repository of built Python packages, you first need to create an account, create a token. You need to run this command on the command line to configure and to kind of authenticate PyPy locally. Make sure you have the correct version number in your PyProject toml. So that's the version number here. I think I linked the wrong thing actually in the slides. So it's at the top. So if you're going to update the version, make sure you update it to 4 to the next one. And then the commands are poetry build, poetry publish, then bam, it'll be on PyPy for people to use. So here I updated to 004, and then people can just run pip install in order to install that package. So yeah, that's the process. All this is also documented on this documentation for PyDev tips. So that simplifies the process a lot. And then if you have a GitHub page associated with the source code, there's this other thing that people often do is creating a release. So then these are the different commands you would run locally to create the release. And then from GitHub, you need to go to this tags page for your project and then create the release from there. I've already done it here, so I don't have that option. But it's described here and also in the documentation. Any questions on the building and publishing? It's really quick because poetry makes it super easy. So if you already were starting to use poetry to initialize your project, install the dependencies, it's already in the format that poetry is happy with to then build and then publish. As long, of course, you have set up having a PyPy account, because obviously they're not going to let any random person just publish in their repository. Yeah.
The things when you build the poetry package for the first time and when you update your package afterwards.
The poetry package or my package? Which one are you talking about? Yeah. So
the same.
So it's going to use the source code that's the current state. So the other thing to make sure is that on GitHub, you've pushed the current state of the code so that the release reflects the package you've published. Because what build does, so let me go to poetry so you can see the outputs of build. Or actually, I can do it here too. I just won't be able to publish since I've already published 0.4. Actually, I can already do it on this dummy project. Poetry build. So when you build it, it creates this tar gz and this wheel file so that now this new does it stand for distribution folder? Dist folder was created where I have this version 1 of the package. And I don't think I'll be able to do poetry publish since I don't have any project on PyPy called dummy project. So normally it should complain here. Yeah, there's no such project like this. So you have to also create that project on PyPy. So let's say if okay, I'm not logged in, but yeah, you would see you can start a project, create a project, and then when you do poetry publish, you want to make sure that the name in the toml, so this name matches the project you've created on PyPy. Any other questions? Okay, so I mean, this is pretty much the A to Z, 0 to 1 to building a Python project and then open sourcing it so that other people can use it. And then if they do pip install like this, other people they don't need poetry in order to pip install your package. So that's the nice thing about these different engines. But if they want to work with your source code, they would need poetry in that case. But already, hopefully, it makes it easier for them to then set up all the dependencies as well when they want to locally work with the code. So yeah, in conclusion, otherwise, so we can wrap up. Yeah, we saw different ways to make virtual environments, Conda, virtual env, how poetry will create them as well, how to navigate an IDE like VS Code, Hydra, which helps for configuration management, for also helping this process of making clean code by separating configuration and code, different libraries to optimize your code, NumPy, joblib, QPy, how you can use poetry to manage your dependencies and package your code and then share it. And then in the documentation, you can find much more stuff on how to actually make documentation for your project, how to make unit tests. So maybe you saw this PyTest command. How would you create those? How would you run those through GitHub Actions? So for example, if you go to PyDev tips, you'll see that there's this little green check. That's because in the backend, there's these tests that are running. So you can see how you would define a GitHub action to run your tests. And then, yeah, much more stuff. It's all described essentially all here in the documentation. So yeah, thank you for your attention. And yeah, we have a little quiz for you as well. Are there any questions, Osvaldo? No? Yeah.
What do other people need to do when I use poetry? When do they also use poetry?
So yeah, if they're just going to install your package like this, pip install, they don't need poetry. It's just like if you pip install NumPy. You don't care how NumPy was built. You just want the final end product of NumPy. If people want to edit the source code of your project, if you did poetry to set up your project, they would also need to use poetry to set up their project. But I would say it's worth it because it does a lot of extra checks to make sure that, okay, you're building things that are compatible with each other. And then there's not these multiple lines you have to run, let's say, to install a new package, add it to your setup. So you'll kind of, let's say, gently nudge people to use better practices when they want to contribute to your code. Yeah. Any other questions? All right, let's then